Hello, I am Aditi Kumar and welcome to another learning session related to deep learning. It is basically the fundamental foundations of deep learning, or maybe I can say introduction to deep learning. So, before starting any modeling related to generative AI or any advanced modeling in machine learning and artificial intelligence, so we need to understand the foundations of deep learning and how it is basically related to uh, any real world scenario, and how basically it is different from classical machine learning models, and what are the ideal scenarios we can use that in for our problem solving in the real world. So we need to understand that first before implementing any technicality related to any deep learning model. Let's start for today. So introduction to deep learning. So I separated into different segments, I can say. So first of all, what is deep learning? Then maybe what are the mathematical intuitions, or what are the mathematical foundations of the deep learning model? And I can say what exactly the backbone of a any deep learning model, especially neural network, and how it is basically different from classical machine learning model. Then finally, what are the challenges with respect to any deep learning model. So let's start for today. So if I am talking about deep learning, so basically we already discussed in our earlier videos. So deep learning is a sub part of machine learning. I basically highlighted here. So this is basically the artificial intelligence. Under the artificial intelligence, machine learning is a sub part of the artificial intelligence. Then deep learning basically the sub part of machine learning. So I can say it is basically related to building the learning capability in the computer system, but again it is very special thing under the machine learning subcategory of artificial intelligence. Then if I am talking about data science here, so data science, in data science, if I'm say, I can say data science is a domain, I can say is a domain, data science is a domain, and I am using both AI, machine learning, that means classical machine learning model, and both deep learning model as a tool to solve our problems in the real world. So for deep learning and for I can say for data science, deep learning, machine learning, artificial intelligence are the techniques or tools for implementation to solve the real world problem. So this is basically the um, relationship between data science and artificial intelligence, machine learning and deep learning. This is basically a very confusing factor always. So what exactly the difference between machine learning and data science? So this is exactly the difference. Data science is not machine learning. So data science is a domain where we are using machine learning as a tool, as a technique. So if I am going to next slide here, we need to understand what is basically the difference between classical machine learning and deep learning. So what exactly the classical machine learning basically? So classical machine learning here, I can say it is basically dealing with the more interpretation into the data. For example, whenever I'm going to just building a machine learning model, as a data scientist or maybe as a developer, I should have better understanding about the data. I should have the domain knowledge related to the data I am going to use in the machine learning model. So here the point here is relies on handcrafted data, handcrafted feature. So I need to pre-process or maybe prepare the data in certain way, or maybe into a certain format, so that our classical machine learning model work on the top of the data appropriately. This is basically say, I can say always machine learning model, as already I discussed in our earlier videos, it is basically fitting into a certain mathematical equation. But again, here fitting into equation is more quietly, I can say more manual way we are interpreting the data, or maybe we are trying to fit in the data. As a developer, as a data scientist, we should have a more understanding on the model, or maybe particular data we are going to use in that building the particular machine learning model. And also interpretability point of view, classical machine learning is good because we are basically fitting the equation and we are understanding the data. Then suppose after the implementation of this particular model, if you are getting a question from business, I can say how can you justify how basically your model is working, then it will be quite easy for us to interpret and we can discuss that thing. Interpretability point of view, classical machine learning is good. So most of the thing I can say the statistical algorithms to learn the hidden pattern of the data or relationship in the data set. So classical machine learning model always, most of the classical machine learning model I can say algorithm I can say it's using statistical algorithm for learning the hidden pattern from the data in the foundation actually. So if I'm talking about here deep learning, so it is basically we don't need to do more pre-processing on the input data set. So it is basically automatically learn from the features or maybe data. I can say from the raw data only up to a certain format we need to convert that particular raw data. Then automatically deep learning model will basically gain the knowledge from the hidden pattern whatever available in our data set. So it mostly deep learning model is suitable in the scenario where we are having the completely unstructured data, or maybe I can say some complex pattern we need to extract from the data. So in that case, deep learning is the appropriate application in such scenario. So here fundamental point of view. So today we are going to discuss basically the fundamental of about the deep learning model. The fundamental of the deep learning model is basically the artificial neural network. That artificial neural network is a very popular in the field of deep learning I can say. So which separates basically the deep learning from the machine learning. So in that case I can say if machine learning basically is a complete picture of the learning, then deep learning basically is I can say some thorough learning. I can say you can thoroughly learning from the data and from the complex data I can say. Forever maybe our classical machine learning model will fail. So this is basically the difference between classical machine learning and deep learning. In the simpler, if the data sets is very simple, or maybe we have the less amount of the data, it is basically very simple, and our problem statement is pretty easy to extract the information from the data. Then we can think basically the classical machine learning model. So if your data set is completely unstructured, we don't have any domain knowledge about that particular data set, and our business problem statement is basically a very complex, then we can think for deep learning model, because in that case deep learning model will help us. This is basically the practicality or practical point of view, it is the difference. And here the backbone is artificial neural network. Again, this is artificial means basically we are implementing the neural network in the artificial way. So the backbone is the neural network. Let's deep dive into the foundations of artificial neural network or maybe neural network in our further slides. So if I can say the importance of deep learning and neural network today, why I am saying here, I need to just give some idea before proceeding to the foundation. So neural network basically forms some foundation of deep learning model. I basically discussed a neural network is the foundation of deep learning model, where we are basically building a network of neurons. So there is a concept here, network, and second concept is the neurons. We will discuss. And I can say neuron is a individual entity or maybe individual concept, mathematical concept. Mathematical concept means this is a fundamental thing which is basically expressed in terms of mathematical language. Network means this is the interconnected node of neurons organized into layers. This is basically the neural network, the network of the neurons. So some examples here where I discussed basically very complex problem statements. We are going to use the deep learning. For example, some examples here are computer vision, your natural language processing, your speech recognition. These are the complex scenario where our classical machine learning model might fail. So these are the area deep learning models or maybe the neural network implementation is a ideal maybe scenario where you can implement the neural network for solving our problems. Let's deep dive into the foundations of any neural network or maybe neuron further. Okay, so if I am talking about neural network basics, which is a foundation of the deep learning model, so first of all, each neuron perform a weighted sum of inputs followed by an activation function. The concept here is weighted sum, inputs, then activation function. If I go to the picture in the first picture here in the below, so we are having n inputs, 1 to maybe I can say x1 to xn, and first one whatever it is there, it is the constant which is known as bias. So first of all, these are the input neurons, input values, and we are having certain weights. Weights mean w1, w2 up to wn. These are the weights. So we are multiplying. Actually, the function here is our y weighted sum equal to your summation of xi wi, and here the last is basically the step function, which is adding the non-linearity on that particular weighted sum. If you can check y hat equal to some function of y, or maybe adding some function of y. Function may be different type of activation problems. It's basically depends on problem statement to problem statement. This is basically I can say a single neuron. This is the concept of single neuron. And if you are interconnecting this in the second figure, if you are interconnecting these neurons to solve a particular problem, then it is basically the neural network. And why it is known as artificial neural network? Because basically it is built on the top of the human neuron actually in the brain. So this is basically the actual neuron. Here it is basically the artificial neuron. The concept here is same. We are implementing here in that particular concept in the artificial manner. That's why it is known as artificial neural network. This is the interconnected network of neurons in artificial way. That's why it is known as artificial neural network. So let's go to the what are the challenges with respect to deep learning model. So we discussed basically the deep learning models are very efficient in certain scenario, or maybe I can say each and every time it is basically giving the very efficient result, but there are still some certain challenges we cannot implement the deep learning model. So first of all, data availability perspective. If the basically the deep learning model requires more data to be trained. And second point is the computational resources. So it takes more resources, resources cost for to be computed, I can say. Because if it is basically working, basically thoroughly learning a particular thing, then that particular concept or that particular technology or that particular model is expecting the high computation power. Otherwise, it will take a long time. Then third point here is the time consuming. Definitely, it will take the time consuming to be trained because it is thoroughly learning the things. And there is a certain, basically it depends completely the particular the size of the network. If the size of network is very big, then it will take more time. It will take more computational power, computational resources. Then fourth point is interpretability. It's quite very difficult to interpret the deep learning model because it is basically internally it is basically learning the patterns available from the data and giving the output. So it is not basically like our classical machine learning model where the interpretability point of view it is pretty easy, but here actually it's working like a black box. That's why it is very difficult to interpret the data. So let's basically summarize in a pictorial manner here. So if I am talking about machine learning model, then again this is basically y equal to f of x. I already discussed it multiple times earlier. So here basically we are trying to fit a equation, or maybe we are trying to find a function which will represent the entire data available in a very generic way, in the generalization manner, so that tomorrow any new data is coming or new instance is coming, we can easily basically define which type of thing it is. We can easily try to fit into that particular equation with reference to the whatever the training we did or whatever the interpretation we did during our training or maybe the earlier with respect to that particular mathematical concept. This is a simple mathematical equation, or maybe equation means here we are getting output, we are representing input as a function of input basically. But if you are talking about deep learning model, so here a single neuron, think about it, classical, this is basically machine learning model means basically I can say some classical machine learning model. This is a single mathematical equation. Again, we are adding some non-linearity, or maybe that depends actually. But again, this is y equal to is a function of inputs. If I am talking about a neuron, single neuron is basically output y hat equal to is the function of weighted sum of summation of xi wi here, or maybe I can say w0 I will add here, because here x are inputs which is constant, which cannot be changed. Wi are the weights or parameters. These are the parameter or weights. As a data scientist or maybe as a developer, we need to assign the correct value, optimized value, so that our model, our mathematical equation will work in a generic way, in a generalization manner. We have only control on this particular words. We have not any control on input data, because input data is fixed. Or also maybe I can say here also function, whatever the non-linear function we are using, that also one factor we have the control what function we are going to use. But again, in the runtime we are setting this particular weights, which process is known as training process. But another factor here, W0, I can say, always we are adding such factor, so which is known as a bias. Here also W0 means here we are giving some constant value with respect to x or input. That's why I ignore that. I only just keep a weight 0. That means certain value, certain constant value I can say. The bias value is always constant. But why we are adding this particular bias? Bias is basically to stabilize the model. So adding the bias into that particular model, so it will basically stabilize during the training process. During the training process means whenever we are finding the optimal value of this particular weights, your W1, W2 up to Wn. And this is basically with respect to one neuron. If I am talking to neural network, then certain neurons actually are connected. Here each and every time this is xi or wi, maybe I can say xi wi is a different value I can say. Again, this is represented with respect to vectors. This is basically the neurons, and each neuron having the same mathematical structure I discussed earlier. And finally, it is basically connected to another neuron, another weight is there, and also bias is there, like this, another neuron, or maybe finally we are basically just finding a output here. And again, this is not fixed, it depends problem statement to problem statement. So thing is basically we are defining the architecture of this particular neuron according to our problem statement. First type of output we are expecting. According to that, we will define the architecture of this particular network, or maybe I can say configuration of the particular neuron. So according to that, we will define. So this is basically the beauty of deep learning model, or maybe I can say artificial neural network. How the human brain neuron is working, the artificial neural network is built top of the same logic or same intuition. That's why before starting any generic, maybe I can say any specific machine learning model technique, or maybe I can say some generative AI related things. So because so in the generative AI we are implementing very complex or maybe advanced machine learning model. Advanced machine learning model means it's not classical machine learning model. This is basically the deep learning model. That's why I thought I will start a different playlist with the deep learning concepts or deep learning specialized architecture of this particular networks, how it is working, or what are the advantages and disadvantages about the different factors or different architecture of the network, so that actually we will have a better understanding parallelly. Sometimes suppose we will get some confusion with respect to any logic, we can refer this particular video. That's why I thought I will start with some different playlist with respect to deep learning, so that it will be very beneficial for understanding the other advanced concept. Thank you for watching this particular video, and please do subscribe my channel and share this particular video to others, so that others can get benefited out of that. And also please put comment on this particular video, so that I can get information related to your expectation related to deep learning models or deep learning concepts, so that later stage it will be really beneficial for me while preparing the content, or maybe while preparing the further advanced topics related to deep learning. Once again, thank you very much for watching this video.